Hi everyone, welcome to this video. In this video, I'm going to walk through step by step to solve 22 SQL interview questions, which are real scenario. These questions are categorized easy, medium, and hard. And I'm going to deep in dive for the details, for the questions, for the problem, for the data, and we can solve it step by step. At the end of this video, you can see we will cover everything in SQL, which are pretty important for the interview, and I will cover all the topics that they are very, very crucial for you to know before going to your interview session. I promise you, if you understand everything that I show you in this video, there is nothing that you are worried about it for your interview session for SQL. If you are ready, let's get started. All right, the first question is easy. Question number 1 is saying write a query that returns the total premium amount for each policy type and then order from highest to lowest. So, as this question shows, this is very simple. We're going to use aggregation function for group by and then just use the sum to calculate the total premium amount per each policy type. And then just order it. So let's go to the SQL Server and solve this easy question. All right, first of all, let's see what we have. We have the database as interview. I select that database and change the view to this database. And after that, just open it and go for the table. We have the policy table. So first of all, let's see what we have. I say select everything from this table. However, in a real world, it's not good to select everything, but just because for the sake of this question, we would like to see what we have. But definitely in a real world scenario, you should have the ERD next to yourself to know what you are working on. I just executed, and this is the case. We are going to use the aggregation function. So we need two columns, the premium amount to just aggregate as a sum, and then for the policy type. So I go for the policy type. We can go with the premium amount, but we need to group by based on a policy type. And when we go with the group by, we need to have the aggregation function. So I say sum, and this should be as the total premium amount. And then we need to order by highest to lowest based on the premium amount. That's the case. And now we can run this piece of code to see the result. We have disability as a policy type. The total premium amount is this number. But the question is saying highest to lowest. So we need to change the direction from ascending to descending. And in this case, life policy type stands for the highest premium amount. And after that, we have health, we have critical, and we have disabilities. So it was very simple question as a question 1. Now we can go for the next question. All right, let's continue with the second question. The second question, again, this is easy. And as I said, we have 10 easy questions, 10 medium questions, and 10 hard or challenging questions. This question is coming from one request. The retention team wants a list of clients who hold more than one active policy, just because they are high-value clients worth prioritizing. This is exactly the real case. In a real case, you never be asked, just write a query to do some that. Those questions that you see in the websites for the SQL practicing. You have the business problem, and you need to know what you are going to do. You are not going to be asked, you are not going to be given the query. We need to know which kind of query we need to run it. So based on this request, we must know which columns we need and what we are going to do. So based on a request, we should have, at the end of the day, we need the list of the clients, only the list of the clients. So we need the client ID, but not all those clients ID, only those that have more than one policy. So it means, first of all, we should use the group by based on a client's ID and count of policy ID. But only those policies that the status is active. And then if the policy ID, if the count of the policy ID is more than one, it means they are having more than one active policy. So let me switch to SQL Server and solve this question. All right, here we can see the table. We have client ID and we have the policy ID, which shows the policy, which policy each client has. And we have the status, we have active, and we have labels. So first of all, we should know we are only working on the active policy. If we go with group by and after that count it, this is so hard because when we go with the group by and when we go with the aggregation function without using the window function, we will lose the dimension of the table. And in that case, we don't know the status is active or not active. So first of all, I prefer to filter the table and keep only the status is active. Only the status should be the active one. Now we are only focusing on the active one. So, but we don't need all columns. We need the policy ID definitely, but we don't need the policy type, we don't need the premium, and we don't need the started and the status. The status is only needed for the filter. So here we need to group by data based on a client ID. And we need to count the policy ID for each of them. We can say number of policy. So if I run this piece of code, we can see the client ID and we have number of the policies. But the question is saying only keep those ones that have more than. So we can say having. Here we need to having because we are, from now on, we are going to filter the group by. So we say having the count of policy ID is more than one. And if I run it, we just have 3 clients. Client 1, 3, and 4. So we very easily could answer the second question. However, this question was still in the easy question categories. All right, question number 3 is saying, return each policy with the client full name, policy type, and a premium amount, but only show the active policies. So here we have 2 tables. One is the client table, which is storing the client information such as client ID, the first name, last name, city, and date of birth. And the other one is the policy, which is the policy ID, client ID, policy type, premium amount, and status. So we need to join these 2 tables, but we should know the relationship. The relationship shows us the policy client ID, which is the same as the policy's client ID from the client table, but the relationship is many to one. It means every single client from the client's table might have more than one policy in a policies table, which makes sense. So what is our strategy for solving this question? We need to first join these two tables together. And after that, for every single policy, we should bring the client full name, policy type, premium amount. But we need to filter and focus only for the active policies. So let's go to the SQL Server. So here, first of all, I'm going to select everything from the policies. Let's first run it, what we have. This is the policy. And if I go with select everything from select everything from the client, let's see what we have in client. So we have two things. We have two different tables, and as we saw, we are going to join these two tables together. Every single client might have more than one policies. So the relationship is one to many. So we should make a decision. We are going to use left join or right join. I'm going to use left join, and the left is the policy because every single client have more than one policy. So I go there, and first of all, I remove the star and say here left join with this table. I'm going to call it as a P and the client as a C, and they are same on the client ID. So the client ID should be equal client ID. One of them is coming from the client, the other one is coming from the policy. But which column we need? From the left side, which is the upper level, based on the questions, we need the policy ID. We need the policy ID. We need the full name, but this is coming from the second table. This is from the policy, so I start with P. We need the full name. So full name is coming from the client. The full name is just the first name. And C, the last name. And we need the policy type. We need the policy type. And we need the premium amount. Both of them are coming from the policy table. Let me run the code so far to see what we have. These are all columns we have. All right. First of all, let me just beautify to have better understanding about the columns that we have. We forgot one more thing, which is the status. I should bring the status to make sure we are working on the active. So first of all, I should say where the P status should be active. And after that, I don't need it. I only need to focus on the active one. And it says for every single policy. Now for every single policy that we have, we are showing the first name, last name, which is the full name. We have policy type, and we have the premium amount. But we need the full name, but we don't have it. So instead of having this one, we can go with uncat. Uncat has just aggregation for two things. We have the client first name and client last name. And we can say as full name. And this is full name instead of having the first name and last name, but we need a space between them. So I just add one more thing, and this is a space between them. That's it. We have first name, we have last name. We have full name, we have policy type, and we have premium. And we are just focusing on policy ID. Every single policy ID has its own, the full name, policy name, and premium amount. All right, now let's talk about question number 4. In this question, we have another requirement, And this requirement is coming from the claims team. They say we need to identify the claims which have been submitted but not yet approved. It means we have a table such as a claim, and it shows all the claims. But as you can see, we have a column, approved date. If this column is null, means the claim has been submitted but still not approved. So we need to filter this table and keep only those the approved date is null for them. Again, so easy question, and let's solve it. Right, here we have all the data for this table, and we are going to filter the data and only keep those or the approved date is null. And we only need the claim ID. We need claim ID, we don't need client ID, we don't need a policy, claim amount, submit. We don't need all of them. But approved date, we need it. As you can see the table, the claim status is approved. It means we have the approved date. So we can use either approved date or claim status. If we are going to use approved date for filtering the data, we should only keep those are the nulls. But if you're going to use the claim status for filtering data, we should keep everything except the approved. So it means if we go with the approved date, we have simpler condition, and it is good for optimization query. But if we go with claim status, we have two options or more than two options, because we have only not approved, and any other status should be included in the query, and it is a little bit heavier query. So I prefer to use approved date instead of the claim status. Everything is fine, and the last thing is that where approved date is null. When approved date is null, it means we are going to just keep those are. If I run it, these are all the claim ID, and I don't need the approved date anymore because the question only asks me keep the claim ID. So these claim ID are those are the submitted but still not approved. All right, another question and another team and another requirement. We have a team as a growth team, and they want to see how many new policies started in the past 25 months. And they should be breakdown month by month. It's a very interesting question because we need to use the date diff or date function. We have a table, and we would like to see how many of them started from today till 25 months ago. All right, here we have our table. And we would like to see how we can solve this question. The process is so easy. First of all, we should make the difference between today's date and the start date. If they are less than or equal to 25, they should be included because they started in 25 months ago. If they are more than 25, they should be excluded. So let's find the difference between today's date and the start date. So I use the datediff function, the datediff function. This function has three arguments. First of all, the month, because the interval is months, we would like to find the month. And the start date, and after that, today's date. There is a function in SQL Server, get date. This is the function for today's date. And we call it as, let's say, length policy. If I run this query, we have a new column, which is length policy, and it shows me how many months ago that policy started. We only need to keep these columns. So we can go with the where function. So I go with where this date diff is less than 25. then we only keep those are less than 25. If we go with above, for example, more than 25, these are more than 25, and they have not started within 25 months ago because they started much, much earlier. So I go with even the less or equal because 25 is also included. These are all the policies have started in 25 months. But the question is saying break down month by month. So we should know how many policy each of them has. So first of all, just because we are going to change the dimension of the table, we are going to use the group by, we need to get rid of some columns that we don't need. For example, we don't need the client ID. We don't need even the policy ID. Uh, policy type. We don't need premium amount, and we don't need the start date and the status. Just these two. Even we don't need. We need a start date. We need a start date because we need to work on a month. We don't need these things because we just used it for filter. Now we can group it. Just group by. We need to group by start dates, but only month of the start date. So I go with months and start dates. We're not going to group by a start date. We're going to group by months of the start date. And here I can say months start date as months of policy. And just because we're using the group by, we need to go with the aggregation function and how many policies. So we need to use the count. We can say as number of policy. And let's run it. In July, we have one. In June, we have one. In August, we have one. For each of them, we have one. So we could answer these questions with aggregation function and date functions. The next question is coming from the different department. Actuarial needs to segment the policies into risk tiers based on one condition on the premium amount column. They say if the premium amount is less than 800, they are low risk clients or they are low risk policy. If this is between 80 to 4099, they are categorized as a medium, and above that, this is a high risk policy. So we need to work with case when or if condition to create a new column for our table to change the dimension. So let's go and solve this question. All right, here we have our data. And again, the first thing is that we should only keep the columns that we needed. The question is asking for policy ID. We need to keep the policy ID. For client ID, we don't need the client ID. Policy type, we don't need the policy type. Premium amount, we need it. And a start date and a status, we don't need it. So I remove all these things because we don't need any of them. All right. Here we need to create a condition. This condition is going to categorize our rows based on the premium amount. So I go and start with case, and this case is gonna end as the name of the column. We can say the risk tier. Inside the case, we should have some conditions. We should say when something happens, then something else. We can say when the premium amount, is less than 400, then it is low risk. And if the premium amount between 400 and 99, then go with the medium risk. Otherwise, we can say even else. We can say else, go with the high risk. These are our conditions. We have three conditions. We have low risk, we have medium risk, and we have high risk. Based on a case, we categorize it. Let's run it to see what we can find. We have one new column at a risk tier. For example, the first row, this is 1200, and 1200 is between the 400 and 4099, so it is categorized as a medium risk, and so on and so forth. We could just categorize the columns based on the actuarial department. Question number 7. Another team, underwriting team, wants to identify the clients who have never ever filled a claim. It means we're going to use two tables and only find the clients which the claim ID for them in a claims table is null. So we should only keep the claim ID is null. After that, find the client's ID from claims table and then see who are in clients table. So we need to work with the join table. Let's start. I go to SQL Server. Okay, here we have two tables. Top one is just the claims, and the bottom one is clients. We need to join these two tables. So I'm going to use a left join, and I'm going to use the left as a claim. So I go with the join and join the claims as a C, the clients as CL. We don't need it anymore. And they are going to be joined based on a client ID because client ID in both tables are the same. So I go with the client ID, which is the same with client ID. And client ID from C is equal client ID from CL. What else? If I go with that, then I can bring the first name and last name to this table. First of all, I'm going to just brought it. Each of them are coming from the client table. So sorry, the claim table. But this one, I'm going to use the concat. And this time I'm going to use the first name and last name. So client first name and client last name. But I need to have a space between them, so I go with like that. I call it as client name. Let's run it to see what we have. We have our table, we have the clients, and we have the claims. But as you can see, the join direction that we did is not correct. Because the question is asking from the client. So we should go with the right join to have all the clients first and then see which of them has no claim ID. So here we have all data and you can see we have all the client's name. And this is very important for us. If we go with the left join, we are just working on those are have the policy or the claim. But our main focus is on the client. Now, we can continue and just use where the claim ID, it means they are, the clients don't have any claim. If the claim ID is null, if the claim ID is null, for example, row number 3, this client, James Patel, doesn't have any claim. If I go with that, these are the clients, and we're only looking for the client name, so I can remove everything and just keep this one. That's it. These are the clients. Nothing have any claims. All right, this question might be a little bit challenging. The data came in from the different system, legacy system or the old systems. So in this table, we have some data which is coming from the legacy system. And the format in that system is not inconsistent with the current system. So we need to clean the policy type. We need to trim it, and we need to only bring it back when the first letter is capital and the rest is the lowercase. And we need to have both the old name and the new name. Okay, here is the case. You can see the policy type we have inconsistent format. We have all capital, we have all lowercase, we have some extra space at the beginning. So we need to clean the data. So most of the time, the data analysts and data scientists are working to query with the data, but sometimes you also need to clean the data to have the consistency, specifically for those columns. They are the key because they are going to map these two tables together. So we can go one by one. First of all, I'm going to trim the policy type. And after that, just change it to the first lower and the first upper, and the rest are lowercase. So first of all, I don't need the premium amount, so I use this for my new query. First of all, I need to trim to get rid of the extra space. So I go with the policy type. And if I go for that, let's see what's the wrong. We have policy. We have the trimmed one, but still we have issue for capital and lowercase. So we can use the combination of substring and lower and upper. Let's start with the upper one. I'm going to use the upper, and this upper is gonna apply for the trim version. But I'm not gonna upper all the trim one. I'm just gonna upper the first letter. So instead of having all of them, I just cut it and say substring. And inside this substring, I put my columns. I need to say, okay, substring from which to where. I say substring start with the first letter and end with the first letter. Only the first letter. That's it. If I run it, you can see I bring back the first letter, and that letter is uppercase. So what about the rest? The process is easy. I just copy that one and paste it there. And in this case, I go with the lower one. And I say, okay, again, substring for the policy type, but start from the second character to when. I don't know, because the lengths are different. So I go with the length, whatever it is, length of the policy type. That's it. Now, if I run it, we have the rest as just a lowercase. So now we know we need to go with the concat. We can go with concat. The first section is the upper section. Upper section. And the next is the lower section. And if I run the query, we have the new column. So I don't need all these things. That's the case. This is the new one, and this is the old one. And they can compare it together. Also, you can change the title of the column. I don't want to change the title of the column because I don't have enough space here. But that's it. We have the old columns and we have the new column, which is clean and neat. All right, the next question is saying the regional team wants to know how many distinct cities each policy type is sold in. It means for every single policy type, we need to count unique number of the cities. So we need to first join the client table with policy and then count unique number of each cities. All right, here we have our tables. The upper level is the client and the lower level is the policy. First of all, let's take a look at the question. The question is talking about each policy type. So the policy table should be the main table or the left table. I go with the policy here. I start coding here. I say the left join. And I'm going to join this table with the client. And they are gonna be same in the client ID. Client ID from client table should be the same as with the client ID in a policy. And I don't need anymore. But we need to make sure about which columns that we need. From the policy type, we need definitely the policy type. So we need it. For the status, we don't need the status. Client ID, we don't need the client ID. And for policy ID, we don't need the policy ID. But what about the client? For clients, we need the city. This is the only column that we need. So if I run it, we have the policy type and we have a city. But the question is saying only count unique number of policy. So I'm going to go with the group by because we're going to aggregate. And the group by should be based on a policy type. And we need to count the city as number of city. But if I count it, I just count, but I like to have the distinct count. So I go with distinct city per each policy ID. If I run it, you can see for disability policy type, we have 2 city. For health, we have 2. And for life, we have 4 different or unique cities. If I don't go, just let me copy this one. And don't go with the distinct, just a simple one. Let's see what's the difference. We have 3 for health. So it means health has a duplicate and also life has a duplicate. But we need only the unique number of the cities. And the last easy question, we have a request from the director. The claim director wants to have a quick view for 5 largest individual claims or in a claim table that filed in 2024. So we have filter for claim date or submitted date, and they're gonna have a report for board presentation. So we need to return the top 5 claims based on a claim amount in 2024 with the claim ID that we have in the same table, client full name we have in client table, policy type we have in policy table, claim amount we have it in claim table, and submitted date in the same table. So let's jump to the SQL Server and solve this question. All right, you can see all these 3 tables. We have the clients, we have the claim, we have the client, and we have the policy. So the main table for us is the claim table because most of the columns are coming from the claim table, and also we would like to rank or find the top 5 the claim amount. So my main table is the claim, but which columns I need from the claim? I need the submit date, definitely. I need the claim amount, definitely. I don't need the policy ID. For client ID, I need it. And for claim ID, I don't need the claim ID. These are the columns that I need from the claim table. After that, I'm going to bring the full name. So full name only for those have the claim. So I go with the left join with the client table. And in that case, they should have the same for the client. So it should be like this way. And they should be same on a client ID. Should be the same as client ID here. This is coming from client. This is coming from claim. Client and claim. But what I need the full name. So for full name, I say the client first name, just plus space plus client last name. I say as full name. And I don't need any more from the client table. What about this one? The client ID is coming from the claim table. Claim amounts coming from claim table, and submitted is coming from the claim table. So far, so good. But still, we need to have something from the policy type. Again, we need to go with the join. I copy that one and paste it there. And instead of the client here, we need the policy. I go with the policy. I'm going to call the policy table as a P or policy. The policy should be matched with the policy ID. Policy ID here is the same as the policy ID in a claim table. So I go for this one. Say policy ID should be the same as the policy ID here. One of them is coming from the policy table. The other one is coming from the claim table. What we need, and we need the policy type, T4 policy type. That's it. And now I run the query. These are all the tables that we need. Okay, for the rest, we should only keep the rows in 2024. So I go with the where function to filter the data. I go with where if the year of submitted date is equal 2024. In that case, we only filter those are in 2024. Just because all of them in 2024, nothing happens, but we need to have the filter. This is for current data. Maybe in future, the data is updated and we have other year. Now it's time to sort the data. So we go with the order by claim amount. And claim amount is coming from the claim table. And it should be descending. And as you can see, the toppest has the best rank. We can use with the window function for ranking, or we can go with the limit. Just because we are using this method as easy questions, I'm not going to use the rank or window function at this moment. So I go with the top. So here I can say just select top 5. Only keep the top 5 and just trim or cut the rest. And as you can see, we have the top in terms of the claim amount. So we have the claim amount, we have the claim ID. We need the claim ID. So in that case, I go with the claim ID. We have the claim ID, we have the client full name, we have the policy type, claim amount, and submitted. So, and we only keep the 5 in terms of the claim amount. We easily could solve these questions. And this was the 10th questions. Now we can move on to the medium level questions. All right, now let's start the medium level question. Question 11, the first medium level question. The finance team needs to track whether the total premium collected is growing month over month. They want to see the percentage change versus the prior month. It means we have a table. The finance team wants to see the current payment amount, and they would like to see the percentage over the time, the comparison between the current premium amount and the previous one. So let's go to SQL Server and solve this question. All right, here we have the table. We can see we have payment ID, policy ID, and other data. First of all, we need to make sure which columns we need to prevent any confusion or complexity in our project. We don't need the payment ID. We don't care about the policy ID. We don't care about the client ID, but we need payment amount and we need the payment date and status. Why status? Because question is saying the collected. So first of all, I need to just filter based on the status for the payment. So I say if the payment status should be equal collected. This is the first condition for our table. Now we have only payment status as a collected. We have payment amount and payment. What is the next? The next step is that the finance team needs based on a month over month. So instead of the payment date, we need to have months. So I go for months as payment date, and I say the current months. This is the first thing, and we need to open and close parentheses. So if I run it, we have months and we have payments. But again, we need to have the total premium per each month. So we need to go with the group by. We need to group by based on a month for the payment date. And we need to have just a sum for the payment. So I say as current payment. And for payment status, we don't need the payment status anymore because we have it in our filter. For month 1, we have total, month 2, month 3, and so on and so forth. This is our main table. We have current months, we have current payment. So I prefer to put it as a CTE, my main CTE. I just call that a table 1. You can call whatever, I just as, and this is just a bit better. Okay. This is my main table. First of all, let's see whether it works or not. I go for select everything from table 1. Okay. So I would like to have the current months start with the current months. And after that, I'm going to have the current payment, But the next thing, based on the questions, we would like to see based on a prior month. So I go and say, what is the prior month for this table and what is the amount? So I say, based on a lag, based on a window function, I go for lag. Lag for the payments. And just because we are using the window function, I should say over. We are not going to partition data because data is already partitioned based on the current month, based on a group by that we did earlier. But we need to have order by because we are using the lag or lead. And the order should be based on the current month and it should be ascending. I call it as the previous payments. You see, for number 1, for month number 1, we don't have any previous payments because it's the first month. But for the rest, we have something. So this is the second table. And again, I prefer to have it as another CTE. So I call it as another CTE, just as, and this is my table, just a bit clean. Okay. Now let's see whether it works. Select everything from, we should call it as, for example, table 2. Select from table 2. Okay. All right, now we make sure the table is working. Now it's time to make a difference between the current payments and previous payments, and then see the change for the percentage. So I say I need the current months. I need the current months. I need the current payments. And I need the previous payments. And here I need to find the differences. So I say the current payment minus previous payment divided by previous payment shows me as the ratio, the percentage. So I say the percentage change. It should be as percentage change. If I run it, you can see the current payment is almost 47% more than the previous. We can just multiply by 100 to see based on the percentage. But in number 4, for month number 4, almost 50% is less. So what we need to provide data for finance, they need to have the months, the percentage change, and the prior month. So they have the percentage change, they have the current payment. This is the result for them. Even we can format it. We can format this number to show the percentage. And even we can make it better and more accurate. So if you have the null, I would like to just show the 0. So instead of having all this number, I prefer to cut it and say coalesce. This is the main number. If this is null, put 0. And this is just the percentage. Let's see. Yeah. And we just solve these questions. We can go for the next one. All right, the next question. The fraud team or the fraud detection team wants to identify the clients with the highest total claim amounts within each policy type because they are potential red flag for review. What this question means? It means for every single policy ID, we should find which record stands for the highest claim amount. And after that, when we have everything, we can see that record belongs to which client. So it means we should use the window function and rank. So let's start it. All right, this is our table. We can see the claims and we can see the client. Let's start with first do the window function for the claims table to find the highest claim amount for each policy type. So first of all, I need to remove the client and I need to focus only on the claims table. Okay, the question said for every single policy type, we should find what is the claim amount. The case is that we can use group function to find the highest claim amount for every single policy type. But in that case, we will lose dimension of the table. It means we will use the client ID. But we need client ID because at the end of the day, we need to join the table with the client table to bring the client information. So instead of using the aggregation table, we should use window function to prevent losing the dimension of the table. First of all, we should make sure which columns do we need. We don't need claim ID, but we need client ID because at the end of the day, we need to join tables. Okay, here we can continue. Okay, now this is the table for us, but we need to find the maximum, the highest. What is the highest total claim for each policy type? For example, life has 5,000, health has 2,000 something. It means we need to rank it. So I go and say rank, and we need to over partition by, we need to rank partition based on a policy type, and order by, it should go with the claim amount, and I call it the rank. And this should be descending because I would like to, the highest number goes for the first rank. We are using rank. We can use the dense rank if we need to have the sequence number. If I run it, for example, for policy type, disability, client ID 105 stands for rank number 1 because she has the highest claim amount. But for health, client 106 stands for the highest one because the claim amount is the highest. Again, for life, client 105 stands for the highest one, the client who stands for also highest one for disability. So we have the rank, but we only need to keep the highest one. So we need to make a CTE. I go with the width table 1 as, and this is my table, and I put all of them inside this table. This is my first table, and I go select everything from table 1. Let's run it. We have everything, but we need to only keep those are the rank is 1 because we only need the highest. So for every single policy type, we have the client. Now we have the table. I can just save it as another city. Let's go for table 2 as, and I paste it there. This is table 2. And now if I select everything from table 2, now we can just go for join the table with clients. I go and say left join because I would like to have everything from my side. Left join with the client, and they should map based on a client ID. Should be equal client ID. Client is C. My table, I call it P. C and P. But what we need from my table, I need the policy type. So I say T policy type. I also need the claim amount, T claim amount. But from the client table, let's see what we have in client table. We have first name and last name. Let's go for first name and last name. I say C first name and C last name. Oh, last name. That's it. If I run it, we have something like that. So we can just make it a little bit better. For example, I can say concat C as the first name, then just put a space, C as the last name. I call it as a full name. This is my first column. The second column, I would like to have the policy type. This is the policy type. And the last one is total amount. This is my entire result. We have the full name, we have the policy type, and we have the claim amount. And as you can see, Aisha Ali, for both disability and life policy type, stands for the highest one in terms of inside the policy type for the claim amount. Question number 13. The CFO or the Chief Financial Officer wants to see how total claims paid accumulate through the fiscal year. So we need a running total to compare against the annual reserved budget. It means we are going to show each month monthly claim paid and the running year-to-date total claims paid. And they should order chronologically. It means for every single month, we should have what is the total amount, and then go with the running total for the month. This is a table that we have, and we're going to solve this question. First of all, we should make sure all the status are the paid. So we go with all of them should be paid. This is the first filter we should make sure. And after that, we should find the month for each of these approved dates. So instead of the approved date, I would like to have the format for approved date. And the format that I'm going to have is just no percentage. Okay. This is the format for months. So instead of the approved date, we would like to have this kind of format. Also, we don't need the client ID, we don't need the claim ID. And I should remove this semicolon. Okay, now we have the claim amount, we have year months, we have the status. Also, we don't need the status because we make sure for each of them we have the pay. So this is the final table so far for us. But as you can see, the year month, we should find the total amount for each. So I go for group by based on this format, and I would like to have the sum for the claim amount, and I say total payments. Total payment for each year month. Right. Now we need to have the running total for each. But just because we have group by here, we should make a CTE from this table. I go with table 1 as, and I put all of them inside one CTE. And I would like to make sure select everything from table 1, make sure it works. Okay. Now we need to have the running total. How we can go with the running total? With the window function. So I go with the window function and I say, all right, I need to have the sum for every total amount. And they should be over, but I'm not going to partition data, but I should order the data. Order by year month, order by year month, and it should be ascending. And that's the case. Here, I'm going to go with running total. So I should use the frames in the window function. So I say rows between unbounded preceding. Between unbounded preceding means the first one. Whoever I am, from the first one. Start from the first one. If I'm here, start from here. If I'm here, start from the first one. Unbounded preceding and the current row. Wherever I am, just start sum of the total payment from the start till wherever I am. If I'm here, all these things. If I'm here, all these things. I call it as running total. If I run it, you can see we have running total. For 24, the January, we have the first one. For the February, we have the total of the first one and the second one. For the March, we have total January, February, March. For April, we have January, February, April, and March. These are the running total. This is the result for the CFO. They can see the running total for every month. All right, question number 14 is saying a policy can be renewed by creating a new policy linked to the same client. It is the renewal process. So we need to identify the clients who renewed their policy within 30 days of their previous policy ending. It means we have a table. In that table, we have some end date and start date. We should see what is the difference between next start date and the previous end date. Let's go to the SQL server. Okay, this is the table, and as you can see, we have client ID, we have policy type, start date, and end date. For every single client, so we should use window function to bring the next start date for every single client ID. If the differences between data start dates and the current end date is within the 30 days, less than 30 days, it means this is the renew. So let's start. First of all, I don't need some of them. I don't need the policy type. I don't need the policy ID. These are the columns that I would like to have. Then, for every single client ID, I would like to make sure I'm going to bring the next start date. So I go for here and say lead of start date. And this should be over, and I should partition data, partition by client's ID, and it should be ordered by start dates should be ascending. And this is next start. For example, for client number 1, start date is 1st of January. And end date is 1st of January for the next year. But what is the start date for the second one? This is 10th of January 2023. Now we should know the differences between the next start and the end date. But we have some nulls. What we can do for those? For those it means they are the last records for the client. It means there is no further services or further policy for that client. We can totally ignore those records. So let me put it as a city. I say with table 1 as, and I call all of them as a table 1. And then I say select everything from table 1 to make sure it works. And now I would like to filter when next start is not null. In that case, I only have the records which client has next start date. Okay, now we need to find the differences between these two. So I go for date diff. The date diff, the first argument is days because the interval is day. What is the first? What is the start date for calculation? It is the next start date. It is the end date, and this is the next start, and I call it as diff. For example, you see for the first one we have 9. For the second one we have 57. So here we need to filter only those are the differences is more than 30. So I say where this one is within the 30 days, sorry, it is less than the 30. Just because we have one where, we have one where here. So this is one condition. And this is the second condition. Now if I run it, we only kept those are, the differences is less than 30 days. But the question said that you need to identify the client who renewed the policy. So we only need to have the client ID. Okay, these are the clients who renewed the services within 30 days, but we need to have the distinct because we have the duplicate. Okay, client 101 and 103 are those clients that renewed the services within the 30 days. Okay, the next question is for loyalty reward programming. The premium team wants to identify the clients whose total premium paid is above the average across all the clients. It means we are looking for some clients who their payment, the total payment, is above the all average payment. So we need again use the window function for all the clients and for every single client to find the total payment for each. All right, this is a case and we're going to solve this case. First of all, I'm going to only focus on the payment table, not the client one. Only the payment table. And after that, whenever everything is ready, I can just use the client ID to look up and join the client information. Here we have some clients, and we would like to find what is the total payment for each. So we can use the window function as the sum for the payment amount over partition by every single client. I go for client ID and I go for order by payment amount. I call it as total payment for each client. You can see client ID. We don't need to order, just clients. Yeah. You see the client ID 101. The total payment is 2015. Client 102, the total payment is 2180. So it is the total payment for each. But we need to have a comparison between their total payments and the average for across. So again, I can use this one and go with the average. I go with the average, and in this time, I'm not gonna partition because I'm gonna for the average for across all the clients. And I can say average payments. The average payment is 1088, but the total payment is different for each. Makes sense because average is across all the clients, but sum is only partitioned by client I. Now it's time to just get rid of the columns that we don't need it. The payment ID, I don't need it. Now the payment amount, I don't need it, and payment status. Only these things are the column that I need. Client ID, total payment, and average. Based on the current columns, you see we have some duplicates. So we need to go only for distinct rows and just keep the distinct one. Now we need to identify the ones have the higher total payment compared to the average. So I go for the CTE, I go for read table 1 as, and I put all of them as one CTE. And then I select everything from table 1, but only keep those are the total payment is above the average payments. If I run it, let me see. Oh, sorry, I forgot to put that. Okay, this is the average and this is the total. These are the only total. They are higher than the average. For example, if I don't put the bear clause, we have client 105. But if I apply the bear clause, that client is gone because the total is less than the average. So this is the table. But we need to join this table with clients table to bring the client's ID. So I go for left join. This time I'm gonna bring the clients and they are common for the client's ID. It's the same as client ID. I call clients as the C and this table as a T, C, and T. Here, I only need to have T client, total payments, total payments. And for clients, I need to have first name. Let's see what we have here. We have first name, we have first name, and we have client last name. Again, let's just concat these two together. And here I would like to have this as full name. Okay. Let's see everything is okay. We have left join. I guess everything is fine. Let's run it. Okay, we have error. Oh, this should come after this one. That makes sense. Client. Oh, this is client ID. Okay. This is the clients, and this is the total payment, and their total payment is above average across all the clients. All right, the next question is saying the operations dashboard needs a summary showing for each policy type. We need how many claims are in the pending status, how many are under review, approved, or paid. Maybe a data team needs it for the dashboard in Tableau or Power BI to show the distribution. So we need to fetch the data for them. This is a table that we would like to have, only claims table. So let's go to the SQL. Okay, here we have our data and we have the claim status that we would like to just show the distribution, number of the claim status based on the policy type. All right, usual, first of all, I remove the things that I don't need. Claim ID, claim amount, I don't need any of them. So we have policy type and we have claim status. So the question said, just because they are going to use it in a dashboard, we need to create a column for each status. So we need to have the combination of case when function and some kind of aggregation function. Let's start. Okay, first of all, we need to group the data, definitely. We need the group by policy type. But for the claim status, we need to count it. But this count is not just a simple count. We should have case when. So let's say start with the pending one. We would like to count the claim status, but not the simple claim status. We should say, instead of the claim status, we should say case and case when. The claim when the claim status is equal pending, then shows me the claim status. That's it. Then show me the claim status. It means I would like to only count those claim status they are pending. And I call it as number of the pending. Let's see whether it works. It's not working. Let's see what's the issue here. We say, oh, we don't need this claim status because we have it. Now, we have number of the pending for critical, disabilities, health, and life. This is for pending. What about the other one? For example, if this is under review. Now let's count it as a new column. 0 under review, 2 for health, and life as 1. What about the other one? The other one is approved, and I change it. Approved. And the last one is paid. 4 different columns, 4 different status for each of them. The first one is pending. This is under review. This is number of approved. And the last one is paid. And this is final result for them. They can use this contingency table in a dashboard to show the distribution. All right, the next question is talking about a regulatory compliance requirement. They need us to identify the clients who had a gap in insurance coverage, any period between the previous expire date and the new date. So we would like to find the clients that the gap, the previous end date and the next start date is more than 30 days. We should have a list of those clients. So let's go to the SQL Server and solve this question. Okay, this is our table, and we have 2 important columns, start date and end date. So for every single client ID, we should bring their next start date. But first of all, I would like to remove the column that I don't need. I need the policy ID and policy type. These are the columns that I would like to have. Only client's ID, start date, and end date. So let's bring the next start date for every client. I go for lead. And the lead is definitely based on a start date. We are going to over partition by client ID. Just because we have lead or lag, we should order by start date. And I call it as next start. Next start for every single client ID. Now we should keep only those they are not null values. This is pretty similar to the previous questions, but the business requirement is different here. So I can use the CTE. I go with CTE as a table 1 and this is my first table. And then I would like to just select from table 1. I'm gonna have everything. And also I would like to have the differences between the started and ended. But before that, let me just filter this next start is not null. This is the first requirement. And after that, we would like to, let me just show the results so far. This is the table. And then we are going to find the differences between next start and end date. We go with date diff. Date diff. We would like to have day. The first date is just the end date. And then the next start, we can call it as a diff. Next start as a diff. These are differences between the start date and next start date and the previous end date. And the question is saying that find the clients who have more than 30 days. So if we can say this is the first where condition, and this is the second one, if it should be more than 30 days. These are the clients that start date, the next start date is started more than 30 days compared to the end date. But we only need to have client ID. So we need to have only client ID. The next one is just a gap between old end date and start date. So the gap is just the gap that we have it. Let's run it. This is just the gap between the client ID. These two clients started the next services in more than 30 days. All right. The question number 18 is about one of the most important KPI in insurance. We're going to find the loss ratio. The loss ratio in insurance is just divide total claims that the company paid to customer by total premium they collected from the customers. It means if this ratio is less than 60%, this is profitable for the company because they collected more than they paid. If this is between 60 to 80, this is acceptable, but if this is more than 80, it's not profitable and it is loss making. We're going to find this ratio for every single policy type. But we have two tables. We have policy and we have claims. So we need to first join these two tables together. And after that, do whatever we want. But the policy type is in the policies. So we are going to use the policies at the left table. So these are our two tables. I'm going to start with the policy table. So I'm gonna cut this one and paste it there. This is for the claim. And I don't need it at this moment. Let's just comment it. Okay. Here is my table. These are the premium amount and the status is all active. But which columns I need? I need definitely policy ID because later I'm going to map. I need policy type, premium amount, and a status. I don't need a status because the question is making me sure that all of them are active. We need to use the left join. I'm gonna bring left join from the claim table. I'm going to call the claim as a claim policy as the P. So it is coming from the P, it is coming from the policy, and also this is coming from the policy. But for the claim, I need only the claim amount. So this is C and claim amount, and both of them are just working based on one common column. This is policy ID. One is coming from claim, the other one is coming from the policy. This is the only just the column that we need, and we have everything. Okay. We need to run it. See. Oh, I forgot to put that one. That's fine. We have premium amount, we have claim amount. So now it's time to work with the ratio. Also, I don't need the policy ID anymore. Policy type. Now we can find the ratio. The ratio is total claims paid divided by total premium collected. But we need to do for every single policy type. So for every single policy type, I'm going to just go with the group by based on a policy type. And I'm going to just sum for the premium. And I call it as total premium. And sum for claim. And I call it as total claim. If I run it for every single policy type, we have total premium, we have total claim. Now we can make a CTE and after that work on that CTE. I go with the CTE with table 1 as I put all of them as a CTE. And now here I can select everything from table 1. Now I can just divide based on a formula. Total claims divided by total premium. So I say total claim divided by total premium, and I call it as ratio. And I would like to multiply by 100 to put as a ratio. This is the ratio. I divided the total claim by total premium. I don't need these things. But we need to have a flag for profitability. We should say if this is less than 60, between 60 and more than 80. So we can make another CTE or use as the new query. I would like to keep the query here. So I'm going to say case and as we can say profitability. And inside it, I'm going to have some conditions. When this ratio, we can say profitability ratio flag. We can say if this number is less than 60, then what's that? This is profitable. This is profitable. I can copy. When the ratio is between 60 to 80, so I can say between 60 and 80, this is acceptable. Else, this is loss making. This is my formula. Let's run it. You can see for the first one, even let me just keep these columns here to make sure we see the ratio. The ratio is, let me just grab the ratio. For the first one, policy ID critical, the ratio is 22%. 22% is less than 60%, so this is profitable. Disability is 55. 55 is still profitable because it is less than 60. But for health, whatever we collected from the customers, we paid for them as a claim, 100%. So this is loss making. And also life is profitable. All right, question number 19 is talking about one of the most common issues for data migrating. The data migration team, while they were migrating the data, they created the duplicate client records. And the duplicate means the same name, the full name, combination of first name and last name, and date of birth. But they have different client ID because the client ID is just a sequential number. So we need to identify the duplicates and keep the only most recent created records. The most created records means the highest client's ID. So we need to find those are and remove from the tables in a database. So let's go to the SQL Server and solve this question. So this question is not only a data analysis question, it's some kind of data engineering also, because we need to modify the tables that we have also. So first of all, let's create the key that shows the duplicate. So first, let's see the data. For example, number one, Sarah Chen initially started 15 of January, but again, she was created on 10th of June. The most recent one is the highest client ID or the most created ID. So instead of working with created ID, I can go with the client ID. So I don't need the created date, don't need the email, but I need some kind of columns here. First of all, I should create the key, which is the same name and date of birth. So I say concat, and this concatenation is just the first name, the last name, and date of birth. And we can call it as P, or let's say client. And this is the client key that we have for every single of them. You see, for example, these things are duplicate because both of them are the same. Also for Robert Kim, 104 and 107. So we don't need the first name, last name, and date of birth anymore. Now it's time to see which of them are duplicate. We can group based on a client key. If that key has only one, means this is just not a duplicate, but if it has more, this is the duplicate. So I create a CTE with table 1 and I call it as the CTE table. And here I can say select everything from table 1. Okay, now I would like to find how many each of them has records. So I'm going to count number of the records or now number of the client ID for each client key. But I use the window function because I'm not gonna lose the dimension of the table. I go for count and I'm gonna count the client ID over partition by the client key. And I'm just gonna total clients for each. And as you can see, some of them has no duplicate, so it means they are not duplicate at all. It should be client. But the question asks us for those they are duplicate, only keeps the highest one. So we need to rank these table. I go and put it as another CTE. I say table 2 as this is my second table, and I say select everything from table 2. And now I'm gonna rank it. I'm gonna say rank over partition by client key, and it should be ordered by total client. So instead of the total client, I say based on a client ID. And I go with the descending to have the highest as the one that I'm going to keep it. For example, here, let me just put a number. For example, here for 106, I'm going to keep it because the total client is 1, but I'm going to keep it. But for 105 and 102, the duplicate client, I'm going to keep the rank number 1. Why? Because the client ID is the higher. Also, for 107 and 104, the duplicate client for Robert Kim, just because the total client is 2, this is duplicate. Again, I'm going to keep the 1 because it has the highest client ID. Now, this is my tables, and I'm going to only keep those are the rank is 1. If the rank is not 1, it means I'm going to remove it from the table. I'm going to remove 102. I'm going to remove 104 and 101. So I should have the list of them. So again, this is my another CTE, and I'm calling it as a table 3 as, guys, this is just a medium question. It's not still a hard question, but it has many back and forth. The deduplication is one of the most challenging part, believe me. This is the table number 3. So select everything from table 3. I'm gonna only keep those are the rank is not 1. If the rank is 1, it means I'm going to keep them. If the rank is not 1, these are the client ID. So I say the client ID. Only keep the client ID. This client ID I'm going to remove from the database. But how I can remove it? Okay, when I'm going to remove it, I should say delete from this table where the client's ID inside what? The client ID exists where? Exists here. This is my subquery. If the client ID is here, delete that record from the client. Okay, but now I'm gonna remove it. But before doing that, I'm gonna make sure I have the ability to come back if the code is not working. So I say begin transaction. This is very important. I'm gonna begin transaction. And I put the begin transaction on top of my table. This is my bit class. Everything is fine. I don't need it anymore. And this is the section. Now I'm going to put 2 things. First, rollback transaction. And if it works, commit transaction. These are my sections just for keeping inside. Okay. First of all, let's see what we have here. If I just select everything from my current table, this is my current table that I have. You can see these are all tables. We have 7 records. Now, I'm going to run all this query from begin till end of these sections. I run it, and let's see right now what we have. If I run it, now we don't have those records. We are happy with this result or not. Maybe we are not happy. So I just roll back the transaction and again do it. Again, we have 7. So again, I do the transactions and I just run it. We are happy. Yes, we are happy. So let's commit transaction and all is done. If I run it, that's fine. And the data in the table is updated. We successfully removed the duplicate. The application is very challenging and it is very important and critical. You should make sure when you are modifying the table, you go with the transaction and rollback or commit to have the ability to just go with the different time traveling between the tables. Okay, the last medium question. Actuarial wants to understand how well policies are retained over the time. For each quarterly cohort, or the policy started in the quarters for every single quarter, how many are still active in 12 months? And we should return the cohort based on the total policies for each cohort and just a ratio, how many of them are still active. It means the ratio is how many are still active divided by the total. Okay, this is our data. If you take a look at the data, we have the status column, but as the question shows, this status is not useful for this specific question. Because this specific question has its own the time period, which is the 12 months. So first of all, I'm going to get rid of the column that I don't need to have. The status is one, policy type, client ID, policy. These are the columns. Start date, end date. Now I'm going to create a quarter. Creating a quarter in SQL Server, it's not as easy as like day, month, or year. We should go with date part function. So we can start with date part. Date part has two arguments. First of all, the interval, and after that, the date. The interval is just a quarter, and the expression or the columns is just these columns. This is the quarter, and as you can see, January, February, March are in quarter one, and these are our cohort. So we can say as cohort. These are our cohort, and now we have categories here. So what's the next? We should find the next 12 months for each records. So we can go with another date function, which is date add. Date add also has three arguments. First of all, the interval. We're going to have the month, and after that, the increment, how many, and what is the expression. So we can say we need the based on months, we need 12 months based on the start dates. We can call it as next 12 months. And this is next 12 months. We have cohort, we have start date, we have end date. Next. We don't need end date anymore because the question is not asking about it. For every single cohort, we have a start date, we have next month, next 12 months. So we need to make sure how many are still active. Active means if for one record, the end date is greater than the next 12 months, it means at the snapshot for next 12 months, that cohort was active. So I'm going to say just the dateDiff function. So I'm going to go with the case when function. I'm going to say case and end as just a flag. And inside it, I'm going to say when the end date is greater than the date added when the end date is greater than the date added, then I should say, okay, when the end date is greater than that one, in that case, you can say this is still active. Else, this is closed, something like that. Just one more. And let's run it. For example, for the first one, the end date is 15 of January, and the next 12 months is 15. So this is closed. Even we can say greater or equal, because equal also makes sense. So the first one is active. But for that one, row number 4, next 12 months is 20 of April, but end date is 20 of October for the last year. So this is closed that time. We only need to focus on those flags they are active. It means the next 12 months, they are still active. So if I put everything in a city, I put table 1 as, I put all of them as a CTE, and I say select everything from table 1, but where the flag should be active, only active one. These are only active one that we are going to focus. They are the active one. But do you think this is the correct way? I don't think so, because we need to have the total policies for every single cohort. With that thing, we filtered the data and we removed all the dimensions. So it's not the good case. And putting the CT was not correct. I come back here. We are going to use the window function, definitely. Okay, we can continue here. Now we are going to find how many records each cohort has. This is just the total number for every single cohort. And how many of them are flagged? So we don't need some columns here. We don't need the start date. We don't need end dates. Even we don't need this. We only need that one. Cohort active. So we need to have two window functions. We need to have, first of all, we need to have just simple count of the flag over partition by cohort. Okay, now this is a table, so I'm going to now make a CTE from this table. Table 1 as, and now I'm going to make a CTE, select everything from table 1. Now I'm going to add one more column, which is just an application function as a window function. So I go for count flag over partition by cohort. For every single cohort, I'm going to count number of the records that they have. We can say total, what's the name? It's just a total policy. Total policy for every single cohort. 3 of them, 3. You see, all of them have 3 policy. All right, now it's time to create another column, which is only the active one. How we can count those are count and condition. So I can copy this code and paste it there. Instead of the flag, I'm going to just bring those flags that are active. So I say case end. Inside the case, I'm going to say when the flag is equal active, then consider the flag column. Otherwise, skip it. So if I run it, just we can say active policy. For example, for cohort number 1, we have 3 policy. All of them are active. But for cohort number 2, we have 3 policies. Only 2 of them are active. That's the thing. So we need to only keep those are they are not duplicates, because we are going to just divide these two numbers together to find the ratio. But we need cohort as one column, total policy, and active policy. And also we need the distinct cohort. So we have just cohort, number of the total policy, number of the active policy, and we need to divide these two numbers together. So I prefer to put all of them as the new table, table 2 as here is my table 2. Select everything from table 2. And now we can just divide these two numbers together. We can say active policy divided by total policy as just a ratio. You see, for some of them we have 0. It's not 0. It should divide 2 by 3. Why it is showing 0? Because we are dividing to integer number. Instead of having active policy, I should cast it as a float. So I cut it and say cast this number as float. And the issue is gone. Now we have the percentage. Even we can just round it, round this one only to decimal. That's it. We have cohorts and we have the ratio. For cohorts, number 1, all of them are just active in 12 months. For quarter number 2, 67 of them are active in the next 12 months. And also for quarter number 3 and quarter number 4. So we can pass this data to actuarial or financial teams to just make sure they understand how well the policies are working. All right, guys, I hope you enjoyed this video. In this video, you saw how we solved 22 interview questions, 10 simple, 10 medium, and 2 hard questions. To be honest, in an interview questions, most of the time you are working with the easy or medium question, and it is so rare that gave you the hard questions. The hard questions need you to know the context of the business. It's not only the writing the query. So most of the time, you're dealing with some medium questions because they can be handled during the interview sessions. But for hard questions, as I said, you need to more deep in dive and know the context, these kind of things. So you don't need to be worried. Even these two questions, for the hard questions, they are beyond for the interview sessions. I hope you crack your interview sessions. See you in the next video.